NASA has a dangerous plan for the recurring asteroid Apophis. Scientists have tested a warning system for deadly asteroids. More than 100 scientists from 18 nations took part in the experiment, which involved scanning the skies on a daily basis for potentially deadly space objects. The system rediscovered for notorious asteroid 99942 Apophis as a result of the scan, and after some time again, Apophis was classified as potentially dangerous. When Apophis was found in 2004, it attracted a lot of media interest since it was predicted to strike Earth in 2029 with a 2.7% chance of doing so. It also briefly had a remote possibility of colliding with Earth in 2036. More observations have revealed that it won't strike Earth in 2029 or 2036, but you never know. Nevertheless, Apophis will pass our geostationary communications satellite in 2029, which is expected to pique public attention greatly. But are we really going to fight it by ourselves? Furthermore, does NASA have any dangerous plan for the recurring asteroid Apophis? In Egyptian mythology, Apophis was a serpent and the enemy of Ra, the sun god. In order to be vanquished by Ra at dawn, Apophis set out every night to bring about permanent darkness on the planet. Apophis was found on June 19, 2004 at the Keat Peak National Observatory in Arizona by Roy Tucker, David Tholen, and Fabrizio Bernardi. Tucker was a beneficiary of a grant from the Shoemaker Near-Earth Object Award Program, which provides funding to advanced amateur astronomers who discover, track, and describe near-Earth objects. Tucker received his grant in 2002. Apophis, just like the majority of asteroids, is too tiny for us to determine its precise size and form from Earth. It is taller than an Empire State Building in New York City, standing 450 meters or 1,500 feet across its long axis, or nearly 5 football fields. Radar scans have revealed this. On its shortest axis, it measures around 170 meters, like the dwarf planet Arrokoth, which NASA's New Horizons mission passed by in 2019. It is probably egg-shaped or maybe dual-lobed. So what now? How is NASA going to prevent us from Apophis? The answer of this question lies in OSIRIS-Rex, which stands for Origins, Spectral Interpretation, Resource Identification Security, Regolith Explorer. Bennu was reached by the spacecraft in December 2018, which had been launched on September 2016. In December 2020, a sample was successfully obtained. On December 3, 2018, OSIRIS-Rex touched down at Bennu. While the mission crew looked for a secure location to gather samples, OSIRIS-Rex meticulously surveyed the asteroid. The fact that Bennu has a surface that is quite rough and full of dangerous rocks was one of the main obstacles. After a year, the mission crew chose the Nightingale sample location, which lies in a 460-foot wide, or 140-meter wide, northern crater. The regolith of rocks and dust is recently exposed and the crater is assumed to be very new. This indicates that the location would probably allow for a pure sample of the asteroid, providing the researchers with information about Bennu's past. On September 24, 2023, OSIRIS-Rex will arrive on Earth after completing 2 orbits around the Sun. Bennu fragments will be returned in a capsule that will separate from the remainder of the spaceship upon landing and enter Earth's atmosphere. Scientists will be ready to recover the capsule when it parachutes to the Utah Test and Training Range in Utah's West Desert. The OSIRIS-Rex mission will reroute to its next target, the possibly dangerous near-asteroid Apophis, after dumping its samples on Earth. Apophis will approach Earth on April 13, 2029, at a distance of 30,600 kilometers or 19,000 miles closer than our geostationary satellites. The OSIRIS-Rex spacecraft will spend 18 months closely examining the asteroid. During this time, it will operate under the OSIRIS-Apex mission moniker, which stands for OSIRIS-Apophis Explorer. The crew has to reroute the spaceship in order to do this. Additionally, it will divide the crew into 2 groups, with one group handling the examination of Bennu's sample, and the other group responsible for maintaining the spacecraft's health and ability to spend a few more years in orbit. The spacecraft was launched in 2016 and will be 13 years old when it investigates the near approach of the Apophis in 2029, which is almost twice as long as its original mission's lifespan. The spacecraft's extended mission will cost an additional $200 million on top of the $800 million mission cost cap, totaling $1 billion, but it will enable researchers to examine Apophis without sending a separate second spacecraft. The majority of the spacecraft's instruments remain in good condition, with the exception of the Canadian OSIRIS-Rex Laser Altimeter, OLA, whose low-energy laser transmitter stopped operating in 2020 following the completion of its primary mission, according to SpaceQ. but the mission team has a big plan for watching Apophis using the remaining set of equipment at their disposal. The spacecraft, in addition to studying Apophis for 18 months and collecting data along the way, by approaching the surface and activating its thrusters, it will perform a maneuver identical to the one it performed during sample collection at Bennu. The asteroid's subsurface will be exposed, allowing mission scientists to learn more about the asteroid's material qualities, according to the University of Arizona. The scientists intend to investigate the asteroid's composition as well as how it will be affected by our planet's gravitational pull when it approaches us. Apophis and Bennu are similar in size, about 1,000 feet or 300 meters wide, but they're different sorts of asteroids. Apophis belongs to the S-type family of chondrite meteoroids, whereas Bennu is a B-type associated with a carbonaceous chondrites that may have transported water to Earth early in our history. However, this is not the only mission planned to investigate Apophis. The South Korean Mission to Apophis project was published in 2020. It was planned to build a spaceship inside the architecture and launch it between July 2026 and January 2027. Apophis was expected to be accompanied by the probe during its historic approach to Earth in April 2029. The mission's primary goals were to map the asteroid, examine its structure, and assess the impact of our planet on it. The project was anticipated to cost $307 million. Unfortunately, the mission was finally cancelled by the Korean authorities. According to Ministry of Science authorities, technical investigation has revealed that the country's industry will not have enough time to create a spacecraft and launch a vehicle by 2027. As a result, the project was cancelled. At the same time, officials claim that this does not imply that South Korea has abandoned its aspirations to examine asteroids. A project for another asteroid mission is expected to be offered in the next basic plan for the development of the country's cosmonautics, work on which will begin in the second half of 2022. Apophis Pathfinder is just another Milo mission that is closely related to planetary defense. Prior to the asteroid's approach of Earth in 2029, Milo's Apophis Pathfinder mission would investigate it with a preliminary flyby. In order to increase understanding of the asteroid's orbit, give preliminary geologic and compositional data, and estimate its mass and density, the mission would make use of a pair of tiny spacecraft. Small, high-heritage payload components like as visible to near-IR and thermal imagers, near-IR point or imaging spectrometers, and a deep space radio communication system that would be used to gather this information. In addition to providing crucial baseline before data for comparison to similar types of during and after measurements of the asteroid by later commissions and missions focusing on the asteroid's extremely close approach to Earth in 2029, such data would provide new scientific information on asteroids like Apophis. The data from the Apophis Pathfinder mission would not only improve the planning for upcoming missions to Apophis, but it would also give scientists more information they need to develop future plans for planetary defense against Apophis and other similar objects. A thorough examination of Apophis will open the door to a greater comprehension of many potentially hazardous asteroids that are circling the Earth. Additionally, these missions will be a fantastic stride in our understanding of Apophis' behavior, aiding in the development of strong defenses against such attacks. Due to Apophis' enormous size, its close approach will be so dazzling that around 2 billion people will be able to see it with their own eyes. The asteroid will first be seen in the southern hemisphere, appearing as a bright star blazing across the sky from east to west, first passing over Australia and the Indian Ocean, and finally crossing the equator over Africa. Fortunately, this amazing and historic occurrence won't be as damaging as initially anticipated. At first, astronomers weren't sure if Apophis' passage would cause Earth to collide. The chance that the Earth's gravitational effects could alter the asteroid in such a way that one of its subsequent trips could result in an impact remained a possibility even after this risk was eliminated, something that was only ruled out this year. But the future is something we can never predict. The energy released if Apophis hits the Earth at 45,000 miles per hour, which is 20 kilometers a second, which is the typical speed of asteroid impacts, would be approximately 10 billion joules. That is 1 followed by 19 zeros. This is comparable to the explosive yield of all nuclear weapons combined, 1,000,000 times more energy than the bombs dropped on Hiroshima, and about 100,000 times more than the energy of the Chelyabinsk meteor. The worst-case scenario for an impact of this size would be if it happened close to a densely populated coastal area or a major population center. If this happened, a multitude of secondary effects including ferocious earth shaking, severe heat radiations, and air shock waves would have deadly impacts. Therefore, even though there is a small probability that it may happen, the repercussions would be severe. For the time being, all we can do is cross our fingers and hope that the Earth's gravitational pull is insufficient to draw the object towards it.